November 1944, Southwest Pacific Area Headquarters. Colonel Harry A. Montgomery stared at the Somerville questionnaire findings spread across his desk. Transportation equipment, 85% deficiency. Signal equipment, 53%. Ordnance, 55%. Engineers, 58%. Montgomery knew these weren't production failures. Washington had built the equipment. The arsenal of democracy had delivered. By 1944, the shortages plaguing earlier training and operations had largely vanished. The materials existed. The supply division had confirmed it. But somewhere between factory and frontline, they had disappeared into administrative chaos. General Breen managed 11 installations across the South Pacific. 400 separate organizations operated within his command. Each requisitioned supplies through different channels. Each maintained separate records. Each used different tracking methods. The ideal flowed in one direction, requisitions backward through a single channel, supplies forward through the same path, clean, efficient, traceable. The reality of 1943 and 1944 was the direct opposite. Montgomery reviewed the San Francisco Port of Embarkation reports. Requisitions arrived daily with staggering deficits in every category, not because the ports lacked materials. The theater couldn't track what it already had. The internal bookkeeping had disintegrated. He found the core failure. Inadequate planning, inept operations, cumbersome organization. But one phrase jumped from the page: faulty procedures and improper record-keeping. The entire logistics system had degenerated into a black hole. Requisitions no longer reflected precise calculations of materials required. Theater commands submitted general estimates of future need. Guesswork had replaced mathematics. The ASF had already concluded that all orders required careful editing based on projected troop strengths. Montgomery leaned back in his chair. The irony was almost unbearable. Japanese submarines hunted convoys, aircraft bombed ports, enemy action designed to strangle American logistics. But the real damage came from within. 85% of transportation equipment missing, not sunk by submarines, not destroyed by bombers, not captured in battle. Simply lost in the administrative chaos of organizations that couldn't communicate. The materials sat in warehouses somewhere across the Pacific, rusting, unused, while frontline units submitted desperate requisitions for the same equipment. Montgomery understood the strategic implication. The Axis had built their entire doctrine around crippling Allied supply chains. German U-boats prowled the Atlantic. Japanese submarines stalked the Pacific. Both enemies believed strangling logistics would win the war. They never realized America was strangling itself. The catastrophic failure wasn't Axis strategic forecasting. It was American data management. Materials disappeared into a system designed by separate entities. Each operated independently. Each maintained different records. None communicated effectively. The chaos did not come from the enemy. It came from the inability to count. Montgomery gathered the questionnaire findings. The ASF needed these numbers. Theater commanders needed to understand the truth. The crisis had shifted from production failure to distribution failure. America could build anything: tanks, aircraft, ships, equipment beyond the wildest dreams of any previous military force in history. But it couldn't track where those materials went once they left the factory. Japanese intelligence analyzed American production capacity. German strategists studied convoy routes. Both focused on external threats. Neither understood the real vulnerability. 85% deficiency in transportation equipment. The United States was defeating itself, and only men like Montgomery, buried in supply division reports, could see it happening. Washington, D.C., 1942. Army Service Forces Headquarters. Colonel Thomas Larkin stared at requisition forms stacked 3 feet high on his desk. The doctrine came from blood-soaked trenches. World War I taught one lesson above all others: shortage kills. The Meuse-Argonne offensive stalled when ammunition ran out. British tanks sat immobile without fuel. French soldiers starved, waiting for rations that never arrived. Never again. The United States Army built its World War II logistics on a single principle: better too much than too little. Maintain supply levels at critical points along the pipeline. Stock calculated reserves at every stage, from factory to foxhole. If a division needs 10,000 rounds, send 12,000. If a port requires 5,000 tons, stock 7,000. The safety margin would prevent another Meuse-Argonne. Strategic plans demanded quantitative support. Political ambitions transformed into specific requirements: rifles, boots, bandages, tanks, aircraft, ammunition, thousands of items. Each requirement checked against raw materials, manpower, facilities. Materials flowed through the pipeline, factories produced, ships transported, depots stored, units received, the calculated oversupply cushioned against disruption. But Larkin saw something his superiors missed. The doctrine required knowing current inventory levels. Only then could planners calculate proper reserves. Only then could the safety margin function as designed. The Army couldn't measure what it had. Depots tracked supplies manually. Clerks filed paper records in warehouses from Brooklyn to Brisbane. Ships carried manifests that arrived weeks after cargo. The pipeline stretched across oceans, through ports, across continents, thousands of items, millions of units, hundreds of locations. Nobody knew what sat inside. Larkin tried explaining the problem to Major General Breon Somervell. The safety margin doctrine demanded accurate counts. Without accurate counts, planners added extra reserves. Those extra reserves created larger unknowns. Larger unknowns demanded more safety margin. The loop fed itself. Somervell authorized basic economy measures. Perfect the inventory keeping, reduce pipeline quantities. But perfecting these systems required time, personnel, resources. The war wouldn't wait. Operations expanded. Each theater competed for priority. North Africa demanded supplies. Pacific commanders requested more. European planners projected massive requirements. Larkin approved requests. The pipeline swelled. Larkin watched the requisition forms multiply. Each form represented supplies ordered. Each order added to the pipeline. Brooklyn Depot reported 50,000 uniforms. Brisbane reported 30,000. Ships carried another 20,000. Theater commanders claimed they needed 100,000 more. The numbers didn't reconcile. A reasonable precaution was transforming into systemic vulnerability. The calculated oversupply designed to prevent shortage was becoming an economic burden. Safety margins multiplied across thousands of items and hundreds of locations. The pipeline bulged with supplies nobody could count. April 1943, Larkin received reports from North Africa. Depots overflowed with winter uniforms. Summer uniforms sat in warehouses stateside. Without accurate inventory, planners couldn't know which season's supplies were actually needed. They sent everything. The doctrine had created a monster. It consumed steel, rubber, shipping space, warehouse capacity. It devoured resources without limit. Larkin understood the terrible truth. The solution to World War I's shortage crisis had created World War II's abundance crisis. The Army had built a system that prevented tactical failure through strategic excess. Now they faced an internal economic war. The enemy was statistical inaccuracy. The battlefield was bureaucratic. The weapons were mathematics and accounting. And nobody knew how to fight it. The Pentagon's planners needed a number, any number. How many shoes would a soldier wear out each month? How many rifles would break? How many canteens would vanish into the mud of 1,000 battlefields? They invented replacement factors. The system was breathtakingly simple. Pick a percentage. Apply it everywhere. A soldier's service shoes in Kansas? Replace 10% monthly. The same shoes in North Africa? 25%. The math was clean. The logic was non-existent. These flat percentages became the foundation of American war production. Factories received their orders based on these numbers. Ships loaded cargo according to these calculations. The world's largest economy mobilized on educated guesses. The Quartermaster Corps embraced the simplicity. Non-sized items, 25% replacement factor across the board. Sized items like uniforms, somewhere between 27 and 50%. The precision was imaginary. The confidence was absolute. Then the shooting started. Real soldiers in real combat destroyed the mathematical fantasy. The .30 caliber carbine exposed the system's fundamental absurdity. In the North African theater of operations, carbines disappeared at 0.4% per month. A negligible loss rate. Planners could relax. 9,000 miles away, the South Pacific told a different story. Carbines vanished at 9.3% monthly. Not damaged, not worn out, gone. Swallowed by jungle rivers, abandoned in hasty retreats, corroded by salt spray, lost in the chaos of island-hopping campaigns. The math was devastating. The South Pacific consumed carbines at 23 times the rate of North Africa. 23 times. For the exact same weapon issued to similar units fighting the same war. The overall combat replacement factor was a fiction. Army service forces had tried to create universal numbers that worked across all theaters. The attempt failed spectacularly. Wide margins of error didn't begin to describe the problem. A 23-to-1 variance wasn't a margin of error. It was proof the entire system was guesswork. The Pentagon responded with bureaucratic triage. In June 1944, ASF slashed the number of items assigned formal replacement factors from 4,300 to roughly 600. If the math didn't work for most items, stop pretending it did. But the damage was done. For years, American factories had produced millions of items based on these phantom percentages. Warehouses overflowed with supplies nobody needed. Critical shortages emerged for items the factors had underestimated. America had revolutionized mass production. Ford's assembly lines could build a bomber in hours. Kaiser's shipyards launched Liberty ships faster than Germany could sink them. Yet nobody could predict how many pairs of shoes that industrial miracle needed to produce. The tables of organization and equipment spelled out unit structures with obsessive detail. The tables of basic allowances specified every item a soldier might need. These documents translated strategy into material requirements with precision. Then replacement factors reduced that precision to arbitrary percentages applied with a shrug. The system worked anyway. American logistics succeeded not because of its mathematical sophistication, but despite its primitive foundation. Factories simply produced more. Ships carried excess inventory. When the math failed, abundance compensated. But in early 1942, that abundance didn't exist yet. They were guessing. They knew they were guessing. They just didn't know they were wrong by a factor of 23. August 1942, South Pacific Command. Admiral Robert Gormley studied the operational orders for Guadalcanal with growing dread. Commander-in-Chief Pacific had sent assurances. CPAC would provide fuel oil, diesel fuel, aviation gas, and stores. The message listed categories but no quantities. Professional language masking complete ignorance. Pearl Harbor had no idea what the South Pacific actually needed. 4,500 miles separated Hawaii from the Solomon Islands. CPAC's staff worked from maps and peacetime formulas. They calculated requirements using European theater assumptions. They possessed no sixth sense for South Pacific operations. Gormley knew they were guessing. He also knew he couldn't prove them wrong. His own staff couldn't help him. COMSOPAC headquarters ran on exhaustion. Gormley's logistics officers fought fires instead of planning operations. They were too overworked to develop proper estimates of quantities. The whole matter of estimates never got the attention it required. Nobody had time to calculate what 16,000 Marines would actually consume. The invasion proceeded anyway. 1st Marine Division hit the beaches on August 7th. They seized Henderson Field, established a perimeter, then waited for supplies nobody had properly calculated. Fuel arrived in amounts someone guessed might work. Ammunition in quantities someone hoped would suffice. Food based on estimates made by men too exhausted to think clearly. The operation muddled through on improvisation and prayer. Marines held Henderson Field through sheer determination. Destroyers made supply runs down the slot because nobody had organized proper convoy schedules. Cactus Air Force pilots flew on fuel reserves that terrified their mechanics. Every mission risked running dry. Every defensive action depleted ammunition stocks that took weeks to replace. The Japanese never noticed the chaos. Enemy intelligence officers watched American positions at Henderson Field. They counted aircraft. They observed naval movements through the Solomons. They tracked Marine defensive positions. But they failed to see the fragility behind every operation. Failed to recognize that American logistics hung by a thread. Failed to understand that one concentrated push against supply lines could collapse everything. Japanese commanders credited Americans with competence that didn't exist. They assumed American material strength matched American tactical aggression. They believed the logistics supported the operations they observed. They never validated the material weakness permeating every aspect of Guadalcanal. Their psychological failure became America's salvation. The enemy failed to follow up opportunities they couldn't see, failed to recognize American shortage, failed to understand Americans could have been cut short with concentrated effort against supply lines. This wasn't victory through superior planning. This wasn't triumph through logistical excellence. This was survival through enemy blindness. The realization chilled commanders who understood what had actually happened. Their tactical victory rested entirely on Japanese intelligence failure. The 1st Marine Division fought brilliantly. The Navy showed extraordinary courage. Pilots performed miracles with inadequate fuel, but success depended on something beyond American control. It depended on enemy mistakes. Luck had been on their side when the enemy failed to follow up. Admiral Gormley knew the truth. CPAC's staff lacked any sixth sense for South Pacific needs. His own staff was too overworked to calculate proper requirements. The whole operation had muddled through on improvisation and hope. They had gambled everything on Japanese failure to recognize American logistical vulnerability. And somehow, impossibly, the gamble paid off. But Gormley understood what that meant. American success at Guadalcanal proved nothing about American logistics. It proved only that the Japanese failed to see the opportunity, failed to recognize the weakness that could have ended American operations in the Solomons before they truly began. The Marines won a tactical victory. The logisticians survived an intelligence failure, the enemy's intelligence failure, not American competence. Early 1942, the War Production Board conference room. Staff officers spread spreadsheets across the mahogany table. The numbers told an impossible story that would force a complete rethinking of American war production. Total program requirements exceeded the nation's entire productive capacity by orders of magnitude. The priority system had created mathematical absurdity. August 1940's original directive established the A1 classification with 10 subgroups. Each rating indicated relative urgency. The WPB assigned aircraft engines A1 priority. Bomber airframes received A1. Fighter fuselages got A1. Tank chassis claimed A1. Naval construction steel demanded A1. Artillery shells required A1. Everything claimed a 1 status, which meant nothing truly held a 1 priority. The system contained a fatal flaw that would prove catastrophic. It operated open-ended with no quantitative limits restricting materials flowing to each priority class. Higher ratings claimed absolute preference over lower classifications, unlimited and infinite preference. Economic reality doesn't honor infinite claims. By November 1940, the WPB elevated machine tools to A1 a status, higher than highest priority. The logic seemed sound since high-priority end items needed high-priority production equipment. This spawned a new problem, as machine tool manufacturers competed with aircraft manufacturers for the same steel. Both held top priority, and both demanded immediate delivery. The contradiction multiplied across every supply chain. May 1941 brought General Metals Order No. 1. Inventory controls for 16 critical metals attempted to curb overbuying and hoarding. Manufacturers could only stockpile materials necessary to efficiently meet required deliveries. But no mechanism existed to determine necessity when every contract carried a 1 priority. December 1941's Production Requirements Plan promised salvation through general allocation. It would balance requirements against actual supply and prevent priorities from violating the principle of marginal utility. The plan looked elegant on paper, but reality demolished it within weeks. The War Production Board discovered the catastrophe in early 1942 during their inventory audit. 10,000 aircraft engines sat in warehouses, fully assembled, tested, and ready for installation. 0 airframes existed to receive them. Engine manufacturers held a 1 priority and consumed unlimited aluminum, steel, and copper. Frame manufacturers also held a 1 priority, but received nothing because engine makers had already depleted the supply. Training units illustrated the broader crisis. The basic equipment plan provided that units in training should receive only 50% of their allowance of critical items, while combat units got 100%. Both allocations existed only on paper since the WPB couldn't meet either target. The system generated claims without regard to supply. Every service branch submitted requirements. Every theater commander demanded equipment. Every training program needed materials. The priorities system accepted all claims as equally valid and promised to fulfill all requirements simultaneously. The promise was pure fiction. Staff officers calculated the devastating shortfall. Meeting just the Army's requirements would consume 140% of national steel production. The Navy needed another 80%. Lend-Lease commitments required 60% more. Civilian économie maintenance demanded 40% minimum. Total claims reached 320% of capacity against 100% available supply. Workers couldn't bridge the gap through harder work, faster production, or longer shifts. The nation's furnaces already ran continuously. Its factories hummed around the clock. Its workers logged impossible hours. Physics imposed absolute limits that willpower couldn't overcome. The priority system had no mechanism to acknowledge those limits. It treated importance as absolute magnitude rather than relative value. It granted unlimited priority to unlimited claims, creating a mathematical impossibility of infinite demand against finite supply. The old methods had reached their breaking point. The system designed for World War I's limited mobilization collapsed completely under total war's demands. Something fundamental had to change. The question was what, and whether that change could come fast enough to prevent complete industrial paralysis. The War Production Board's statisticians believed they had found the answer. The Production Requirements Plan would bring order to the chaos. Finally, a systematic approach. Finally, real data. For the first time, manufacturers would report actual material requirements against inventory. The WPB would balance total requirements against available supplies. No more guessing, no more priority inflation. Just cold mathematics and rational allocation. The plan launched in 1941 with genuine sophistication. Forms flooded out to every war contractor in America. Report your steel needs. Report your copper requirements. Report your aluminum consumption. The data would flow upward. The allocations would flow downward. The system failed almost immediately. The WPB organized itself horizontally separate branches for each critical material. The steel branch allocated steel. The copper branch allocated copper. Each branch operated independently, making decisions in isolation. A tank manufacturer might receive approval for 12,000 tons of steel to build 500 M4 Shermans. The steel allocation came through perfectly. Production could begin. Then the copper branch denied the 47,000 pounds needed for electrical wiring. The tanks sat half-built on factory floors. Thousands of man-hours invested. No copper to complete them. Meanwhile, a shipyard received copper allocations but insufficient steel. An aircraft plant got aluminum but no ball bearings. Manufacturers quickly gamed the system. The WPB asked for estimates. Contractors wildly inflated them. If you asked for what you actually needed, you'd never get it. Better to pad the numbers and hope something arrived. The statistical foundation crumbled under these inflated estimates. Garbage in, garbage out. But the truly spectacular failure came from the classification system itself. The WPB needed to categorize thousands of manufacturers across America. Someone had to organize this chaos into comprehensible categories. The bureaucrats made a decision that would become legendary in administrative absurdity. They classified all converted war plants based on first quarter 1941 production, what they had made in peacetime, before Pearl Harbor changed everything. A factory that built tractors in January 1941 remained classified as a tractor manufacturer, even after it retooled completely, even after it began producing M4 Sherman tanks by the hundreds. Statistical reports showed tractors where tanks rolled out. They showed automobiles where aircraft engines roared through testing. They showed agricultural equipment where artillery pieces took shape. The WPB's sophisticated planning system couldn't see the actual war economy. It saw a ghost economy that no longer existed. It allocated materials based on peacetime production patterns to factories that had transformed entirely. The industrial mobilization for war history would later describe this as the most amazing mass error in the entire mobilization effort. Thousands of factories misclassified. Allocation decisions based on false data. The most sophisticated planning apparatus ever assembled, blinded by its own categorization scheme. The Production Requirements Plan had introduced the necessary statistical infrastructure. It created the forms, the reporting systems, the data collection mechanisms that a planned economy required. But it revealed the fundamental limitation of horizontal planning. You couldn't optimize steel allocation independently from copper allocation. You couldn't balance material requirements without understanding actual production. You couldn't plan an economy you couldn't see. The WPB had built a magnificent machine for rational allocation, then fed it nonsense data and wondered why chaos persisted. November 1942. Behind locked steel doors in Washington, IBM machines hummed through the night. Operators fed punch cards through electric accounting machines in an endless mechanical symphony. These climate-controlled rooms held the key to Allied victory. The Controlled Materials Plan represented a complete reimagining of industrial control. No more percentage allocations, no more bureaucratic guesswork. CMP focused on three critical materials: steel, copper, aluminum. Vertical allocation from raw material to finished weapon. Mathematical precision replaced human estimation. The system's foundation was the bill of materials. Prime contractors submitted detailed bombs for every weapon, every vehicle, every piece of equipment. These documents specified the exact gross stock weight of material required. Engineers calculated inevitable losses in processing spoilage, rejects, testing, every source of waste. The computational challenge was staggering. Technical services expended 18,500 man-hours preparing data for BIM Job 0012 alone. Engineers analyzed 17,000 individual items. Each item demanded its own calculation. Each calculation required verification. The computation of material requirements consumed nearly 1 million individual punch cards. Each card represented a single data point in the massive calculation. Each technical service needed 17 complete decks of punch cards. The machines processed them continuously, 24 hours per day, racing toward the final deadline. Without electric accounting machines, human calculators couldn't handle the volume. The complexity defeated manual methods. Only IBM's mechanical computers possessed the necessary speed and accuracy. The company's tabulating machines made the impossible routine. Guards controlled every entrance to the punch card rooms. The machines never stopped. Operators worked in shifts around the clock. Readers fed cards through, machines executed calculations, printers generated results on continuous forms. The mechanical rhythm never faltered. CMP's sophistication extended beyond simple material totals. Engineers calculated requirements adjusted for lead time. This created the critical nexus linking bills of materials to master production schedules. A tank needed steel today, but processing that steel required months. Copper wire for aircraft demanded different lead times than aluminum sheet. Engineers aligned every timeline perfectly. The shift from PRP to CMP marked a fundamental transformation. The Priorities Review Board had failed because human judgment couldn't scale. Bureaucrats couldn't track millions of competing demands. Political pressure distorted allocations. The system collapsed under its own complexity. CMP eliminated the human bottleneck. Mathematical models replaced committee decisions. Data processing replaced negotiation. The machines calculated optimal allocations faster than any board could meet, more accurately than any human could estimate. This was industrial warfare's hidden revolution, not the assembly lines journalists photographed, not the factories newsreels celebrated. The real transformation happened in locked rooms where punch cards clicked through readers and electric motors spun calculation wheels. Those machine rooms won the war. Allied victory required getting the right materials to the right factories at the right time. CMP made that possible. The million punch cards processing through IBM machines represented more than data. They represented the mathematical foundation of American industrial dominance. November 1942 marked the moment engineering precision conquered bureaucratic chaos. Systems thinking defeated administrative confusion. The future of warfare became computational. Behind those locked doors, electric accounting machines processed the calculations that would crush the Axis powers. February 1944, Norfolk House, London. American and British planners transformed statistics into weapons. The battle of statistics erupted over a single question: how many landing craft would actually work on D-Day? American officers insisted on 95% serviceability. British planners demanded they plan for 75 to 85%. Overlord hung in the balance. Lieutenant Colonel William Nuckolls spread Pacific operational reports across the conference table. Tarawa, Kwajalein, Eniwetok, the data showed consistent patterns. American landing ships and craft achieved 95% serviceability across hundreds of amphibious operations. Mediterranean numbers matched Salerno and Anzio, validated the Pacific experience. British logistics officers studied the American data. They acknowledged the performance. Then they rejected using it for planning. "We must plan on 85% for LSTs," the British insisted. 75% for smaller craft. They pointed to their older vessels. Their Mediterranean fleet carried battle damage. Their maintenance crews worked with limited spare parts. Their philosophy ran deeper than numbers. It is very much better to plan on too little and then have a bonus, they argued, than to face an unexpected shortage at the last moment. Nuckolls couldn't accept this logic. American crews maintained newer vessels. Pacific maintenance standards exceeded Mediterranean practices. The 95% figure came from real operations, not theoretical models. Planning for less meant fewer troops on the beaches, fewer supplies in critical first hours, unnecessary delays in follow-on waves. The British wouldn't yield. Older equipment failed more frequently. Conservative estimates protected against disaster. Hope made poor planning doctrine. They'd rather discover extra craft than face shortages during the assault. The dispute paralyzed overlord planning. Every percentage point determined force levels. At 95% serviceability, the assault proceeded as designed. At 85%, planners needed additional LSTs that didn't exist. At 75%, D-Day itself faced postponement. American officers presented maintenance logs. British planners countered with risk assessments. Both sides defended legitimate positions. Neither could prove the other wrong. The philosophical divide ran deeper than mathematics. Americans optimized for maximum assault force. British planners hedged against catastrophic failure. One approach risked under-resourcing the invasion. The other guaranteed it. Staff officers began calling it the Battle of Statistics, not a fight over tactics, not a debate about German defenses. A fundamental disagreement over numbers that would determine how many men hit Normandy beaches on the first day. The calendar showed no mercy. June 5th approached. Eisenhower needed final numbers to commit forces. Montgomery required definitive craft allocations to position divisions. The entire invasion plan waited on resolution of a statistical dispute between allies. The irony struck everyone in Norfolk House. The greatest amphibious assault in history involved millions of men, thousands of ships, years of planning. It could fail before the first shot. Not from German resistance, not from Channel weather, from an inability to agree on a percentage. February dragged into March. American officers brought more Pacific data. British planners held their positions. The numbers remained unchanged. The deadlock continued. Overlord required 2,493 landing craft of all types. The serviceability dispute affected every calculation, every troop allocation, every supply estimate. The invasion's success depended on whose statistics would prevail. The battle of statistics had to be won before the Battle of Normandy could begin. Both sides understood this reality. The question remained unanswered. Whose numbers would determine the fate of Europe? January 1944. A conference room in London. American logistics officers stared at the survey results spread across the mahogany table. The numbers told an absurd story. Equipment for 18 divisions sat in British warehouses. Boots, blankets, uniforms, mess kits, mountains of quartermaster supplies. Enough to clothe and feed an entire army group. Signal equipment told a different story. Radios, field telephones, switchboards, cipher machines. The stockpile could equip exactly 5 divisions. The lead planner looked up from the report. His face had gone pale. "Gentlemen, we can't communicate." Overlord was 4 months away. The greatest amphibious invasion in history. Thousands of ships, hundreds of thousands of men. Complex coordination across air, sea, and land. And they had radios for 5 divisions. Someone in the room laughed. Not from humor, from the sheer absurdity of it. They'd shipped enough socks to supply 270,000 men. But they couldn't establish radio nets for a coordinated assault. The imbalance wasn't an accident. It was built into the system. Bolero had prioritized bulk tonnage over critical components. Ship manifests measured success in gross weight, not operational capability. So the blankets shipped first. Always. The radios waited. The problem cascaded. Without proper distribution systems in Britain, cargo piled up faster than it could be processed. British ports choked on American supplies. Warehouses overflowed. Equipment sat in shipping crates for months. Then came the proposal that made shipping authorities physically ill. Use ships as floating warehouses. Load them with single commodity groups. Park them in British harbors. Unload selectively as needed. The practice was abhorrent under normal circumstances. Ships existed to move cargo, not store it. Every day a vessel sat idle represented catastrophic waste. World War I had proven each day's delay in ship turnaround meant a loss equivalent to $10,000. But the ETO had no choice. By May's end, they demanded 155 commodity loaders for Overlord. Ships that would cross the channel loaded with specific supplies for selective discharge on French beaches. 155 ships, sitting idle, waiting to become floating supply depots. Meanwhile, the Atlantic remained a battleground. U-boats still hunted convoys. Every merchant vessel mattered. And now 155 of those precious ships would become warehouses. The irony burned. America's industrial might had produced an avalanche of material. Factories ran triple shifts. Workers assembled equipment faster than it could be shipped. But the wrong things arrived at the wrong times. Quartermaster supplies for 18 divisions, signal equipment for 5. The planners in London understood the implications. On D-Day, American forces would storm Normandy beaches wearing fresh uniforms and carrying full packs. They'd have spare boots and extra rations. But coordinating the assault, communicating between units, calling for naval gunfire support, they'd improvise, make do. Hope 5 divisions worth of radios could somehow serve 18 divisions worth of troops. The lead planner closed the survey report. Outside, London prepared for the invasion that would liberate Europe. Inside, logistics officers confronted an uncomfortable truth. They'd measured the wrong things, prioritized the wrong supplies, built the wrong stockpile. And now, 4 months before Overlord, they'd run out of time to fix it. The conference room at the Pentagon, late 1943. Admiral Royal Ingersoll leaned forward. His question hung in the air like smoke from a gunshot. 2 Army representatives shifted in their chairs. Neither man spoke. The question seemed simple, almost mathematical. Supposing that the requirements submitted by the various Army and Navy commanders for something amounted to, say, 250 ships, Ingersoll said. His voice measured and precise. And the total capacity to receive is only 200 ships. Who makes the decision as to where the reduction to 200 ships should be made? He paused. Let the numbers sink in. The first Army officer cleared his throat, began to speak, stopped, started again. His answer wandered through organizational charts and theoretical chains of command. It satisfied no one, least of all himself. The second officer tried. His response proved equally inadequate. Words without substance, procedure without authority. Ingersoll waited. The silence grew uncomfortable. Neither man could answer very satisfactorily. This was the heart of the problem. Not a technical failure, not a production bottleneck. This was pure organizational paralysis at the highest levels of Allied command. 50 ships worth of supplies, desperately needed equipment, critical ammunition, vital fuel, medical supplies, replacement parts. All of it sitting in warehouses because no single authority could make the most basic allocation decision. The question exposed everything. The United States military still operated under what planners politely called the traditional separation of Army and Navy supply and administrative systems. Traditional. The word masked catastrophic dysfunction. Army commanders submitted their requirements. Navy commanders submitted theirs. The numbers exceeded capacity. And then nothing. No clear authority. No unified command. No single decision-maker. The system defaulted to negotiation. Compromise. Political maneuvering between services. Sometimes the Army got priority. Sometimes the Navy. The criteria shifted like sand. Ingersoll's question cut through the bureaucratic fog. It demanded a name, a title, an office. Someone who could make the call. That person didn't exist. The organizational chart showed no joint logistics authority, no unified supply command, no single point where Army and Navy logistics merged into coherent strategy. The gap wasn't an oversight. It was the system working exactly as designed. Except the system didn't work. Ships sat idle in harbors. Warehouses overflowed with supplies destined for nowhere. Combat units ran short of ammunition while tons of it rusted in depots. Medical supplies expired before reaching field hospitals. All because no one could answer Ingersoll's question. The Admiral understood what the silence meant. He'd exposed the vacuum at the center of Allied logistics, the place where decisive action should happen, where someone should have authority to prioritize. To allocate, to decide. That vacuum had a cost, measured in delays, in missed opportunities, in operations postponed. The two Army officers finally offered their unsatisfactory responses. Ingersoll nodded politely, moved to the next agenda item, but the question remained, unanswered, unanswerable. 50 ships worth of supplies, no one authorized to decide their destination. This was how empires fought wars, with brilliant engineering and catastrophic organization, with industrial miracles and bureaucratic paralysis, with the capacity to build anything and the inability to decide where to send it. The conference continued. The vacuum remained. 1944. The numbers told two stories of mathematical warfare. In America, the Army Service Forces faced a revised procurement goal of $24.25 billion. The shortfall, $764 million, just 3.2%. After years of desperate scrambling, American production had achieved near-perfect precision. The crisis had migrated. Production was solved. The line item shortages that had plagued commanders gone. The desperate telegrams demanding more trucks, more ammunition, more everything silent. The immense industrial machine hummed with mathematical perfection. But victory wasn't won in Detroit's factories. It was won in the distribution chain, in the timing, in the logistical processes that moved selected portions of the military machine into precise positions across the Pacific. The final blow against Japan was controlled by mathematical mastery, getting the right supplies to the right place at the right time. The Pacific revealed the real crux, not overall shortages, not insufficient shipping tonnage, but difficulties in the distribution process itself. The challenge of orchestrating thousands of vessels across 9,000 miles of ocean from San Francisco to Tokyo. American mathematicians had solved it. The Japanese couldn't. Their supply lines told a story of mathematical catastrophe. In 1942, losses of military supplies en route to battle areas, 160,000 tons. 3% of material shipped. Acceptable, sustainable. The price of doing business across their vast Pacific empire? By 1944, the numbers had transformed into a death sentence. Japanese losses en route, 1,405,000 tons, 33% of everything they shipped, 1 in 3 tons of ammunition, fuel, food, equipment gone. Destroyed by submarines, sunk by aircraft. Lost to the mathematical precision of American interdiction. The crossing point had arrived. American production shortfalls, 3.2%. Japanese distribution losses, 33%. the mirror image of mathematical warfare. One nation achieving near-perfect efficiency, the other bleeding to death in the supply chain. This was quantifiable strangulation. Every Japanese offensive now had to account for the mathematics of loss. Ship 3 tons, receive 2. Plan for a month of combat, starve in 2 weeks. Resource desperation forced tactical adaptation. Banzai charges weren't just cultural, they were mathematical necessity. When 33% of your supplies vanish en route, you can't sustain prolonged combat. You attack with what you have. You commit everything to one desperate thrust because resupply is mathematically impossible. The American focus on balanced, controlled flow of material had been validated by enemy collapse. Japanese commanders faced an impossible equation. They couldn't produce more, American submarines would sink it. They couldn't distribute what they produced, 33% losses guaranteed. They couldn't fight without supplies that would never arrive. The Pacific War had become a demonstration in applied logistics. American mathematicians had created distribution networks that delivered 96.8% of required supplies across thousands of miles of ocean. Japanese logistics had collapsed into a 33% loss rate that made sustained combat operations impossible. Victory wasn't achieved through superior courage or better tactics. It was calculated in percentages, measured in tons delivered versus tons lost. Won through the mathematical mastery of distribution that strangled an empire. The final blow came through logistical processes, through the timing of moving military power into place, through the mathematical precision that ensured American supplies arrived while Japanese supplies sank. 3.2% versus 33%. The numbers told the story of mathematical warfare perfected. August 1945, Southwest Pacific Area Headquarters. Colonel Harry A. Montgomery reviewed the final ASF performance metrics. Transportation equipment, 85% deficiency in November 1944, now fully accounted for. Signal equipment, ordnance, engineers, all tracked with mathematical precision. 9 months had transformed chaos into order. Montgomery studied the depot productivity numbers. October 1943, receiving and shipping employees handled 2.9 short tons per 8-hour man day. August 1945, 5 boxset of 9 short tons. Productivity doubled through systematic redesign. The materials hadn't changed. The warehouses remained the same. The transformation came from precision in tracking, efficiency in handling, mathematics replacing guesswork. He turned to the communication metrics. January 1945, 52.5% of overseas radio communications delayed beyond 2 days. August 1945, 12.1%. Delays reduced by 76%. The radios hadn't improved. The operators hadn't suddenly become faster. The system had been redesigned to eliminate bottlenecks through quantitative analysis. Montgomery remembered the black hole of 1943 and 1944, requisitions based on estimates, records maintained separately across 400 organizations, materials lost not to enemy action but to administrative paralysis. The Japanese had hunted convoys, the Germans had bombed ports, both believed strangling logistics would win the war. Neither understood the real vulnerability, America's internal chaos of faulty procedures and improper record-keeping. The Axis strategic doctrine had failed because it analyzed the wrong problem. Montgomery reviewed the CMP system documentation. 3 critical materials: steel, copper, aluminum. The system succeeded by addressing the systemic flaw, balancing production within available supply through real-time data. The shift from flat replacement factors to factor analysis based on actual loss rates proved revolutionary, not 10% for all service shoes. Precise calculations: 0.4% carbine loss in one theater versus 9.3% in another. Granular data replaced broad estimates. The transformation hadn't come from building more. America's industrial capacity had always been staggering. The achievement came from managing what already existed. Unmanaged industrial capacity was merely an economic burden. Montgomery had seen it firsthand. Materials accumulating in warehouses, storage facilities overwhelmed, production choking on its own excesses. Mathematical precision transformed resources into strategic advantage. The arsenal of democracy had delivered beyond any previous military force in history. But in 1944, 85% of transportation equipment sat lost in administrative chaos. The victory came from outmanaging complexity. Montgomery gathered the performance reports. Depot productivity doubled, communication delays reduced by 3/4, chaos mastered through systems engineering. Japanese intelligence had analyzed American production capacity. German strategists had studied convoy routes, both focused on the visible war factories, ships, material crossing oceans. Neither understood the invisible war. The battle fought in requisition forms and inventory records. The triumph of quantitative methods over administrative chaos. The final lesson was clear. Industrial scale meant nothing without administrative mastery. Production capacity became strategic advantage only through mathematical planning and systems designed to manage complexity. Montgomery closed the reports. The metrics told the story. From 85% efficiency to complete accountability. From chaos to precision. From burden to weapon. The quiet victory. Systems over chaos. Mathematics over guesswork. The war won not just in factories and battlefields, but in the unglamorous work of counting and tracking with quantitative precision. America had learned to count, and that made all the difference.